really useful feature that some programming languages come with, but not all of them, is error control. Error control usually means that there is something that is related to the keywords try and catch, or try and accept, or try something. You're basically giving the code a chance to fail at something and recover, right? So sometimes we are in a position where you expect some user input and the user just doesn't cooperate, or you read some data files and there's some garbage in the data files that you didn't expect. And instead of all the analysis going haywire or aborting because of an error, you can say, well, in the case of an error, do this, right? So formally, the definition is there's some kind of keyword try, and then there's a block that's being executed and tried and tried and tried. And if some statement in that block fails, it might, in those programming languages, generate an error that can be caught by the catch keyword, and then the block is executed here. So for Python, the keyword is try : and then the statements are being executed here, except, and then there's an optional error code. So you can just say try all of this except any kind of error, then you would leave this blank and just say except : So for any error, you do this, some kind of graceful exit, or just skip this line of input. I don't care what the error is. I want to move on to the next line. Okay, you can have a different number of exceptions that are being caught here. So you can have except user error, do this, except number isn't an integer error, do this. And you can have a finally statement where, once all of this is done, you execute whatever is going on here. So try and accept, you have to have at least one try component, and then one accept component that may or may not have an error code. Here's an example for iterating through a list and dividing, right? So, lists of values don't all have to be the same type. We talked about that in a different video. So if we have a list of values that is 1, and then the character X and 3, and we iterate over that and we say for X in that list of values, we want to try to calculate the reciprocal of whatever is in this list of values. So 1 over X is saved to R, and then we print the reciprocal of whatever the value is here of that integer in that list of values. So that is X now. In the first iteration, this is 1 is, and then there's some floating point number that comes out of this R, okay? Except for the exception that, maybe we're trying to divide an integer by a string. And that is an example I've showed in a previous video already. And now we can still run through the code for the next value in our list and calculate the reciprocal, despite there being an error that Python normally would not recover from. This is quite useful. It's also useful to kind of see what these exceptions are, and perhaps then diagnose how to fix these issues in the future.